This video covers two sections, section 1.5 and 1.7. The first section is 1.5, where we are just going to review some of the basics of how to convert back and forth between decimals, percents, and fractions. We're not going to worry too much about operations of decimals, because a lot of those are really easy to do in your head or using a calculator. But we are going to look at, first of all, how to convert back and forth between decimals and fractions. Specifically, when rewriting a fraction as a decimal, I like to use what's called the Nike method. Most of you will remember the Nike, or think of Nike as a clothing company that makes shoes and articles of clothing. But they're well known for, also, they have a saying, which is just do it. The reason why I use this to help remember what to do is because you just need to do the operation that a fraction says. What's this operation right here that's represented by the fraction bar? It's the operation of division. So when you have 5 over 16, that's like saying 5 divided by 16. Now, of course, 16 does not divide into a whole number 5, so we have to add a 0. But since 5 is the whole number, that means the decimal point goes right there, which means we have to also put a decimal up here in our answer. And so now we can ask, does 16 go into 50? And of course it does. It goes in 3 times, and 3 times 16 is 48, which gives a remainder of 2. Now we don't want remainders, so we're going to add another 0 and bring that down. 16 does go into 20. It goes in once. 1 times 16 is 16 with a remainder of 4. We got to bring down another 0. 16 goes into 40 twice. 2 times 16 is 32 with a remainder of 8. Bring down another 0. And now we get something that works out, because 16 times 5 is in fact 80, which gives us a remainder of 0. So 5 over 16 is the same as 0.3125, which you can see right here in your answer. Of course, you could also divide it on a calculator, but the point is to remember, whether you use a calculator or you do it the long division way, the way we convert this to a decimal is we just divide. Now, going backwards to writing as a fraction as a decimal, rewriting a decimal as a fraction, we need to look at what place the last digit's in, and this 6 is in the hundredths place. Well, that's what we use to help us rewrite it as a fraction, because that means that this 0.56 is equal to 56 hundredths, which we then want to try to reduce like we have been doing with fractions. Divide that by 2, we get 28. Divide that by 2, we get 50. Both of those are still even, so let's do it again. 14 over 25. So that's my answer in reduced form, 14 over 25. Okay, now let's go ahead and move on to percents. First, I want to ask you, what does percent mean? Well, it means per, and then the second part of the word is cent, which you may recognize as 100. So this means, percent means per 100. So how do you change a decimal to a percent, or vice versa? Well, if we want to rewrite a decimal as a percent, we need to move the decimal place 2 places to the right, just like that. So this is going to be 35, and now the decimal is after the 5, so it's 0.7%. And then moving back the other way, if I want to rewrite a percent as a decimal, that's the third example, I want to go ahead and move the decimal place now back the other direction 2 places, which means we need to add a 0 in there, and so this is going to be written as a decimal 0.05. Okay, the last example is how do we rewrite a percent as a fraction? And you need to remember that percent means per 100, so 60% means 60 per 100, which both the top and the bottom are divisible by 10, so I can divide by 10, which gives me 6 over 10. Of course, these are both divisible by 2, so this is 3 over 5. So this equals 3/5. 3/5 is equivalent to 60%. Alright, now we can move on to the second section. It was a short one. The second section talks about exponents and order of operation. It's important to talk about exponents first because exponents are part of order of operations. So, first of all, very simply, exponent notation is a way of representing repeated multiplication in a simpler form. So let's go ahead and fill in the blank there. This would be multiplication. Repeated multiplication in a simpler form. For example, if I have 3 multiplied by itself 5 times, 3 times 3 times 3 times 3 times 3, that can be written in exponential form as 3 raised to the 5th power, where the 3 is the base and the 5 is the power. Just another way of writing repeated multiplication. So if we look at some examples, 5 to the 3rd means 5 times itself 3 times, which is of course 125. 2/5 squared means 2/5 times 2/5. We'll review here. We multiply fractions, we multiply straight across. 2 times 2 is 4. 5 times 5 is 25. And then one more, this is negative 1/2 to the 3rd, so this means negative 1/2 times negative 1/2 times negative 1/2. If we multiply 3 negatives, our answer will be a negative, and multiply across on the top. 1 times 1 times 1 is 1. Over the bottom, 2 times 2 times 2 is 8. So this is negative 1/8. Alright, so it's just a little review of exponents. Now we can move on to order of operation. And I want to start looking at order of operations by first taking a look at 2 simple sentences in English. And the only difference in these 2 sentences is there's a comma in the first one. The first one, if I were to read it, it would say, "Let's eat, Mommy." Whereas the second one, there's no pause there. There's no pause after eat. "Let's eat, Mommy." The second one is, "Let's eat, Mommy," which I think you would agree makes a significant difference. So that's kind of why order of operations are important to math. It matters which operation we do first, otherwise the outcome is different. There's a difference between asking Mom to eat and wanting to eat Mommy, just like there's a difference between, in this example, adding 2 plus 3 first, which is 5, and then multiply by 4 to get 20, or first multiplying 3 times 4 is 12 and adding 2 to that to get 14. So we have to have a specific order that we always follow. And a lot of times the way people remember the order is they remember this memory tool called Pemdas. And so the P stands for parentheses. The E stands for exponents. The M stands for multiply. The D stands for divide, the A stands for add, and the S stands for subtract. Now, it is a little bit more than this though, because when we're talking about parentheses, we're talking about things that are more than just parentheses. So we could be talking about parentheses, something in there, but we could also be talking about brackets, or we could be talking about a fraction bar, something like 2 plus 3 over 5. That means that we have to group the top and add it first before we can divide. So things like that. Also, one more, absolute value. That's a grouping symbol. So really any grouping symbol is what we classify in the parentheses. That's what we do first. Okay, exponents, we just talked about what those are. But multiply and divide, let's make a little note here. We have to do multiply and divide at the same level. These are at the same time. These are at the same time moving left to right. And then the same thing goes with add and subtract. At the same time moving left to right. So we'll group those two pairs of operations together. So let's go ahead and look at an example here. If I do this first basic example, I have two operations. I have a subtraction and a multiply. If I start at the top of this list and I move down, multiply definitely comes before subtract. So the first thing I would do here is I would leave the subtraction and I would multiply. 7 times 6 is 42. Once I have that, then I can go ahead and subtract. 12 minus 42 is a negative 30. Point with that first example though is that you have to multiply before you subtract. Moving on to example B, well, the two operations are divide and multiply. If I go back and look at Pemdas, divide and multiply are at the same time, but I don't do multiply before divide. I do it at the same time, moving left to right. So I'm actually, if I'm moving left to right, I'm going to do the divide before the multiply. So if I divide first, 18 divided by 6 is 3. I still have the times 2, and 3 times 2 is 6. Okay, moving on to example C. Well, here we have some parentheses, so we're going to want to simplify what's in the parentheses first. And there's actually two sets of these, so I'm going to look at the innermost ones first, and inside the innermost ones I have an add and a multiply. Remember, we multiply before we add, so this is going to be 2 times 4 is 8 plus 7, and 7 plus 8 is 15. So we simplified that set of parentheses down. Once you simplify the first set of parentheses, the problem looks like this. But we're not done. Now we have these brackets here, which is another grouping thing. And we have operations within the brackets. I have 3 next to 15, which is multiply, and I have plus. Again, do the multiply first. So 3 times 15 is 45. I still have, though, plus 4. 4 plus 45, of course, is 49. So the second, the outer group, simplifies to 49. So now I have 5 times 49, which is 245. Okay. The very last example we have here is one that now introduces exponents. And it says we have parentheses and exponents. Now, according to Pemdas, I need to take a look at the parentheses first. So everything that's inside here, I need to simplify that first. Now within that, we need to still follow the order of operations just like we've been doing. And the order of operations say any exponents first. So I need to take 4 squared, which is 4 times 4, or 16. And I also need to take 3 squared, which is 3 times 3, or 9. Everything else stays. So I have plus 3 times 5 minus 9. Parentheses. Now we keep going with order of operations. I have add, multiply, subtract. I multiply. So this is 15. So we have 16 plus 15 minus 9. And then now we're just to add and subtract. So remember with Pemdas, add and subtract at the same time, but we move left to right. So we're going to go 16 plus 15 is 31 minus 9. 31 minus 9 is 22. So I have 8 times 22, which is 176. And that does it for this video. Thank you. Make sure you do your homework.